Domain adaptation for hate speech detection using LSTMs. Hi, I'm Inas, an 8th SEM student of Anjuman Institute of Technology and Management, and I'm excited to talk to you about our project, that is hate speech detection, along with my teammate Muraffa. We are here under the guidance of Professor Madhura NK. As many of you know, hate speech is currently a huge problem that is actually spreading, and it is growing, and it particularly affects communities such as people of religion or people of color or certain race, etc. And this has a way of impacting a vulnerable population. Table of contents: Introduction to hate speech, understanding the problems and the problem statement, motivation, what led to the project development, abstract, project objectives, application snapshots, that is our web application, project contributions, system requirements, literature survey, design and methodology, the process, results and observations, advantages and disadvantages, the challenges that we have faced all through, future work, conclusions, and references. Let's see the introduction to hate speech. It is a speech that threatens individuals based on race, religion, ethnic origin, national origin, gender, or, or any other such factors. And hate speech hurts, it demeans us and deters us from the real issues. Unfortunately, hate speech is prominent on social media. However, there is no current system that explicitly filters hate speech. It's such a major problem that the technology industry has to build a powerful system for hate speech detection. This has become so viral on social media these days that it becomes very difficult for the authorities to go through each and every content and profiles of these mischief makers. So, we propose to implement a system that can detect and report hate to the concerned authorities using advanced machine learning with natural language processing. Now, what is machine learning? It is an application of artificial intelligence in which the system automatically learns without being explicitly programmed. We give a certain amount of training data and the machine learns. Then we give our testing or the data for prediction and it predicts the results. NLP, it is natural language processing. It is also a subfield of AI and linguistics that deals with the interactions between computers and human natural languages and how the programs must analyze and process large amounts of natural data. Understanding the problems and the problem statement. With the rapid growth of internet and social media, news and fake news, and owing to a lot of misconceptions, which is both factual and fake, people tend to become very reactive in social media, mainly Facebook and Twitter. People may talk ill about others' religion or race or community. This would eventually lead to physical riots or communal unrest, and it is imperative to stop the spawning of this hate speech. This online discrimination has led to the rise of communal hate. So, this got me thinking, what if we could develop an AI system that could detect hateful speech from the internet? And in this regard, we have decided to propose a novel method to detect and report hate speech. We have designed a machine learning system along with NLP that detects hate speech from the internet posts, and believe me, this is not as easy as it seems. NLP is very complex because the speech can be expressed in many different ways. So, our goal here is to extract these keywords that promote hate, and we are aimed at improving the end results by giving more and more training data and feature development. The project objectives: we start off by gathering the data set. Now, for any machine learning model, we need to feed it with lots and lots and lots of data, training data. So what we do here is we analyze the various existing online data sets, and we also perform a web crawling over the Twitter using a particular hashtag. Here we have used the hashtag CAA and hashtag NRC because that's what is going on in India right now. So here we've collected data set and we have built a custom CSV file or a custom data set suited to our project. The second objective is to design and implement a simple conventional machine learning model to detect hate speech. We have used linear SVC with logistic regression, which Murafa will explain later on. Then we implement the same project using a deep learning model, that is transformers, to detect hate speech. We can see later on that the accuracy varies between the conventional and the deep learning method. You will see that the accuracy of the conventional model has a little lesser value than the deep learning model. The accuracy of simple conventional model will be around 79% in this project, and the accuracy achieved for deep learning model using the state-of-the-art techniques is around 94%, so which is quite high. Then we explore the potential of transfer learning applied to the problem of hate speech detection. We'll see what transfer learning is later on. And deep learning, it is a subset of AI in machine learning that has networks capable of learning unsupervised or unstructured data. This is nothing, I just wanted to share my experience throughout the project. What we did was we started off with Trello. We started organizing our project work and tasks. On this application, we have few sections here: to do, ongoing, deliverables, done, archive, and goals to be accomplished. So we actually define the tasks, and that is our ongoing task, and then we move it to done after we have completed that particular task, and what next to do, what are the deliverables, what are the goals to be accomplished. This is all that we've maintained this way. It's a pretty old screenshot, I guess. Next, we'll see how the front end of our web application looks like. So this is the front end. We have our logo here. We have the enter hashtag field where we will enter our hashtag, and then we'll analyze this hashtag. Here we have entered CAA. Let's see what results we get. We got an accuracy of 79%. So this application was developed using Flask. It is a web interface, and it's a micro web framework actually, written in Python. It is used along with scripting languages. So here we have used it with Python. You can use it with JavaScript as well. It is simple to use and it requires lesser tools and libraries. So before you run the app, you will need to install a few modules. You can do that using the command pip install whatever module name. So first you'll have to do from Flask, import Flask, and then you will have to install a few modules. That is done using pip install. Next, let's just brush on the project contribution. The first one is papers referred and selected. These are the tasks by me and Murafa. What we have done, like 50% is done by her and the rest is done by me again. So we've referred papers, both of us. Then we have online data sets that we referred and selected to build our custom data set. We have taken the NLP course from Stanford, pre-processing task. We actually listed down what all pre-processing tasks we have before we actually get into the classification. Like here in India, we have tweets in Hindi as well, so we'll have to separate that because this machine learning model is built for English tweets, so we'll have to clean a lot of data there. Then we'll have to remove stop words and punctuations, URLs, and whatnot. That will be explained by Murafa in the pre-processing slide. Next, we have the visualizations in the form of bar graph and word cloud. Here, this bar graph represents the number of CAA tweets over the years or months. Word cloud is another data visualization technique. It is used for representing data data or text in a pictorial form. So, greater the size of the text, higher the frequency or importance of that particular word in the dataset. Then we come to named entity recognition. This is where you actually look for named entities in a particular tweet or in a particular tweet or an internet post, you can say. Here it reports the number of human names or people or organizations or names of companies, monuments, countries, etc. As the name suggests, named entity. So it will detect that. Frequency dictionary is simple. It is the number of words, a number of times each word appears in a particular document. Next, we have to understand the simple pipeline and the transformers. Simple pipeline is for our first phase of the project, which we will see right now. And the next phase of the project is using the state-of-the-art techniques, that is the transformers. We all know what a simple pipeline is. It is when you give the output of one module to the input of the next. So here we see a flow diagram for the simple pipeline. We have a data set in CSV format, that is comma separated values. So we give this input data and we split this into data frames using the pandas library. Then we use NLTK tool to pre-process and to check the spelling, lemmatization, stemming and all that, which you will see later on. Tokenization using count vectorization. Tokenization is basically splitting of a sentence into words. Like you have the car is red. Now the is one word, car is one word, is one word, and red is another word. That is tokenization. Each word is a token here, and the and is, these are not of importance, so we will just focus on the car and red because that will help us to predict the results. Then we use TF-IDF. After that, we classify it using SVC or naive Bayes logistic. Here we use linear SVC with logistic regression. Finally, we predict on the training. Data, and then we give our testing data, and we compare the results between the two. Next phase, we have the domain adaptation using LSTM. Here, the domain adaptation is actually it is a subfield of AI and transfer learning associated with machine learning. This is where we use the learning from one source domain to be applied to a related target domain. Transfer learning, it is the improvement of learning in a new task through the transfer of knowledge from one related task that has already been learned. Say the model developed on race can be applied to the model used for religion. That is transfer learning. We transfer the learning from one source model to the next target model. We use Hugging Face transformers here. Hugging Face is the company names. So here we will see a screenshot of our terminal where you give the input as your tweet First, you start off by from transformers, import pipeline. Then we assign the pipeline of sentiment analysis to a variable called NLP. Then we do NLP of that particular tweet, which gives us the result as a negative or positive tweet. Finally, you can see the results on the screen. State of the art technique is referring to the highest level of development reached at that particular time as a result of the methodologies adopted. So here, let us see, in our project, we will first apply machine learning techniques and neural networks for text. And let's understand what is text first. You can think of it as a sequence of characters or words or phrases or sentences, paragraphs, or anything else. But in this video, we will consider text to be a sequence of words or tokens. For every distinct word that you have in your dataset, you will have a feature column which you will effectively vectorize into each word with one hot encoded vector, that is a huge vector of zeros that has only one non-zero value. That will be the one is assigned to the token present inside that entire vector. We'll see that. Here we have the cycle diagram. We start off with accumulation, that is the gathering of data or tweets here. Then we clean it by applying pre-processing techniques and normalization. Then we perform tokenization, which involves lemmatization and stemming. Will be explained by Muraffa. Finally, we classify it into hate and non-hate. TF-IDF vectorization. Before that, we'll see that there are generally two main approaches to hate speech detection. The first one is a lexicon-based approach. We will first want to split some given text into smaller tokens. This process is called tokenization. This process in this process, we will count the number of times each word shows up, and the resulting tally is called the bag of words, which I'm sure many of you have come across. Next, we look up the subjectivity of each word from an existing lexicon or an existing database for emotional values that is already pre-recorded by researchers around the world. And once we have those values, we can compute the overall subjectivity of our text. It will give us whether the particular text is positive or negative. The second approach uses machine learning. If we have a corpus of, say, tweets that are labeled either hate or non-hate, then we can train a classifier on it, and given a new tweet, it will classify it as either hate or non-hate. So which approach is better? I'll tell you, using a lexicon is easier, but the learning approach is more accurate, and that's what we're looking for. There are subtleties in language that lexicons are bad at, like sarcasm. They say one thing but mean the other. But neural networks, on the other hand, can understand these subtleties because they don't analyze text at face value. They create abstract representations of what they learn. So they are called vectors, and we can use them to classify our data. That is what we see in TF-IDF vectorization. TF-IDF stands for term frequency inverse document frequency. Now any model, any machine learning model will be able to read values only in numbers. So we have to convert these words into numbers. So that's how we do it. We compute the value for each word after extracting the keywords from the document, and we assign TF-IDF scores. This TF-IDF score is actually a numerical value, say 0 or 1, to each word in a document. System requirements. Actually, you can run this project on any PC that you have, because obviously it will be Windows 7 or later, or Mac if you have. So the tool we used here is NLTK, language is Python, RAM 1 GB or more, hard disk 6 GB or more, and any Intel processor would do. Now, before I let Murafa take over, I have something. I just have a thought. Now, social media literally have their own free speech rights to decide that certain voices and messages should be excluded from their platforms. I understand the moral satisfaction of calling for the suppressing of these ideas that we hate, but experience shows that if we censor this, it does more harm than good. So, would we rather trust ourselves to uh, should we rather trust ourselves and our fellow citizens to ignore and rebut messages that are hateful, or should we rather trust the government or the corporate entities to take those decisions away from us? I'd say the lesser of the two evils is making our own decisions. Over to you, Murafa.